benefit because we are good people in any case. So let's put just 3. Do you agree? Okay, let's put 3 here. Okay, now economical benefit with respect to indicator 3. Indicator 3 is impact on the landscape. Okay, I don't know, one may say the ecosystem is more important than the landscape, so I could put here a value greater than 3. Because if I put a value greater than 3, it means that the economical benefit is, okay, let's put, I don't know, 7. Okay? But if you disagree, just tell me. If you say, no, 7 is too much, the landscape is important, we can put 5. No problem, because actually, once that you get in a real situation, this is a difficult step to agree on this. And what one could do is, try to reach a mediation. It's not easy, but anyway. And now, economical benefit with respect to the touristic appeal. Okay, here one could say, touristic appeal is important because it brings money. So you don't want to lose it completely. So, okay, let's put 2 here. So basically, what we concluded with this first evaluation is that the economical benefit is an important of 3 with respect to ecosystem, 7 with respect to landscape, and 2 with respect to the tourism, which means, that ecosystem is more important than landscape, and tourism is more important than both. These considerations are important to reach consistency. Okay, let's go to the next row. Importance of ecosystem with respect to the economical benefit. We already know the reply. It's 1/3. Correct? Oh, sorry. Correct? Okay. Importance of the ecosystem with respect to landscape. We said that it's more important. So, what should we put here? I don't know. Let's try to put 4. Let's try to put 4. Of course, here the trick is to try to be consistent. Now, importance of the net benefit with respect to, importance of the ecosystem with respect to tourism. We said that is less important, so let's try to put 1/3. Or maybe 1/2. Let's put, usual mistake. Let's put 1/2. Okay. Now, importance of landscape with respect to the economical benefit. I think we already know the reply is 1/7. Okay, importance of landscape with respect to ecosystem, I think, let me see, in this case,
1/4.
Is 1/4, correct. Good. And then, this one was not compared yet. Importance of landscape with respect to tourism is less important. I would say, let's try to put 1/5 at least. Okay, now there is symmetry, so I think here we have 1/2. Yes, 1/2. And then here we have 2. And here 5. Is it symmetric, this matrix? Yes, it's symmetric, correct. Should be. Yes, it is. I think it is. Okay, that's good. Now, we have to check consistency. And we have to compute the weights. In order to do that, we have to compute the eigenvector, right eigenvector, and eigenvalues. So what is the right eigenvector? So if we call this matrix as A, I just would like to remind you how it is defined because it's important for us at this stage from an operational point of view. If you have a matrix A, the right eigenvector, let's call it x, is such that the multiplication of A times x is equal to lambda x, where lambda is the eigenvalue. Yeah. Look, the eigenvalue, it's not just one, they are four, but if the matrix is consistent, they converge, they assume the same value. And therefore, they are four in this case because the matrix has dimension 4. And you will see that indeed they are four, and we expect that they have the same value. And usually, if the matrix is not consistent, they don't have the same value, and then we pick up the maximum one. Okay. But in any case, it's important to know the definition because we can make a check once we found the eigenvalue and eigenvectors. Okay, now I think the easiest way to compute the eigenvalue and eigenvectors is to pass to R. So let's upload this matrix in R because with a couple of instructions we compute eigenvalue and eigenvectors. In Excel I'm not sure how it can be done, and I think it is possible, but it's probably longer. So let me take the R window here. No, this is not the R window, sorry. Here, the R window, and let me I put the R window just here above the Excel file because it's easier for me to read. And let's define the matrix PR1 equal array dim zeros, dim equals C 4 and then we can start PR1 1 1 is equal to 1, PR1 1 2 is equal to 3, PR1 1 3 is equal to 7, PR1 1 4 is equal to 2. Okay, and now let me go back. PR1 2 1 is equal to 1/3. PR1 2 2 is equal to 1. PR1 2 3 is equal to 4. PR1 2 4 is equal to 0.5, so 1/2. Good. Just 1 second, I have to reduce the size of this window, otherwise. Good. Okay, I move forward. PR1 3 1 is equal to 1/7. Three 2 is equal to 1/4. 3 3 1 and 3 4 is 1/5. Okay, and now I just need 4 1 1/2, 4 2 2, 4 3 5, 4 4 it's 1, and this is my matrix, which is correct. Okay. When you're ready, we move forward. Okay, somebody's still working, so because you are working on it, maybe that you're moving forward. Let me put it politely.
I'm finishing.
You know, if I was you, I'm always used to make at least many things at the same time. So when I'm attending meetings and we get stuck in some discussions that don't resolve, I'm starting doing something else. So I can imagine that even when you are attending lectures, you may start doing something else. And it would be, you know, I think we have to be multitasking, so I don't complain if absolutely. Okay, you are reading? Okay. Now, couple of instructions to compute eigenvalues and eigenvectors. So, first of all, let me expand the window now, the R window, and let me go back to the file that you can download from my website. And you see the file gives the instruction to define the matrix and then to define the element of the matrix. We already did that. What we need is this instruction here. Eigen, name of the matrix, symmetrics equal false. And because you know this matrix, indeed, it's not symmetric. I said symmetric before, but it's not symmetric. Because symmetric would be if the lower part was identical to the upper part with respect to the diagonal. This is not like so. This is, the lower part is 1 over the upper part. So probably the right name, but I'm not sure, is antisymmetric. But I'm not sure for that. The only thing is to point out that I was wrong when I said symmetric. It's not symmetric. It's symmetric in a way that once that you define the upper part, you can compute the lower part, but it's not identical. Did you get what I mean? Okay? So let's now write this. Here 2 equal eigen, here 1, symmetric equal false. That's it. But if you look at the names of PR2, because PR2 is a list, you have value vectors, but if you look at it, you still don't understand really what's going on here. But I think indeed that there is already I think we can already point out one thing. Let's look at the values, what we need in the first one. And the other ones, first of all, they are complex numbers, but you can see that the first and the last one, they are complex, but with the imaginary part that is 0. So they are real indeed. And you can see that the first one is close to 4, and the other ones are close to 0. So basically, what we need is the first one, which should be 4, is not 4, so it means that it's not consistent. And in order to get the eigenvector, because they are in complex form here, you need the following instruction, which is module. You have to take the module of PR2 values. Values. Basically, okay, let me see. But in this case, I got the module, I got the eigenvalues, not the eigenvector. So the eigenvector, I think I have to take the first one. I think for the eigenvector, I have to take the real ones, the first one, yes. I think we have to take this. Let's try to do that, okay? Let's try to take the first one. And let's see then if with the first one we got to the right value according to this definition. And let me anticipate that if I take the first one, which means the first column, I have to rescale it because this doesn't sum up to 1, so we need to rescale this. But in any case, let me copy on the Excel file this. So it's 0.82, 0.29. I go to the Excel file. Eigenvector 0.282, 0.29, 0.09, 0.48. Yes, I think it works. So basically, I just summarize. I copy here the first column of the results from the routine. Are you with me? Okay. And then you see that the sum is 1.68. And here I'm scaling it because I need, for definition of weights, I need to scale. Okay. That's fine. And now what I did here is a check. I checked if according to this definition and according to the value of according to this definition, what did I do? I found the product, I computed the product of the matrix times the scale vector. And if you go here, you see, it's just, if you look at the formula, it's B4, which is the first element of the matrix in the left corner, left top corner, times H4, which is the first element of the eigenvector, plus C4, which is there. It's second element of the first row of the matrix times the second element of the vector. And then this is the product, basically, the product vector. It is basically the result of A times X. And this should be equal to X times lambda. And in fact, here in the following column, I am computing simply the product of the computed vector divided by the eigenvector scaled. And I find the eigenvalue. And you see 4 eigenvalues here. They should be all 4. They are not. Okay, they are not because the matrix is not consistent. And one more thing, you may ask me, why did you use the eigenvector rescaled instead of the eigenvector not rescaled? It doesn't matter. You know, it doesn't matter because the result is, in terms of the eigenvalue, is always the same. Okay? If I computed the product vector by using the eigenvector not rescaled, I would obtain the same result in terms of the eigenvalue. I hope it is clear. So basically, I rescale the eigenvector of the matrix because for definition of weights, I need to rescale it when I need to solve my problem. But this is just a rescaling that I had to do because in my problem, I need to rescale the elements of the eigenvector, but I could do without that if I didn't have to solve my problem and just to find the eigenvector of the matrix. I hope I am clear. Is it clear? Okay. Now the problem is that, as you see here, there is an eigenvector that is 4 times 17. In my opinion, is a bit too large, but we now should make the check of the consistency. And how can we do that? First of all, we have to find, you may remember this, I don't remember I think we called it CI, but I'm not sure. I'm opening now the PDF, which is lambda max minus n divided n. So this is 0.17 divided by 4, which means like something like 0.04. It's something like that. Now we have to find the quantity. I think it was CRI, which is equal to CI divided by something that was like RI. Now I'm opening the PDF. It's 0.04, and then I need this table, which I displayed to you. I show you on Monday. I get it. Let me see. I'm not sure if it is this one or if it will be. Is 0.9. So 0.04 divided by 0.9, which is probably 0.05, something like that. So this is acceptable. Let me say that it's acceptable, okay, in terms of consistency. But still, even if it is acceptable, we may wonder whether we can reach a improved consistency of the matrix. So, let's see. Can I go back to R? Are you ready? Okay. Okay, let's see this matrix. So where can improve it? I think probably we can try with by putting 5 in 1 in 2, 3. Let's try like this. So let me try PR1, 2, 3, equal 5. And then of course we need to put 3.2 equal to 1/5. Let's try. I think it didn't improve much. Okay, let me see. Yeah, now it's a bit improved. I'm looking just at the first eigenvalue and I see that it got closer to 4, sorry. So it's a bit improved, but still it's not perfect. Let me see if I try to put here 3 instead of 1/3. Yeah, it's now it's close to 4. It's getting close. Not really. Let me see if we can improve. If we 2.5. Let's see if we can improve again. Not sure. Maybe that now I am exaggerating a bit. Okay. So basically, this changed in 0.83, 0.26, 0.1, and 0.49, 0.11. So let me try to go in Excel and change it. 0.83, 0.26, 0.1, if I will remember, 0.11, and 0.49. Yeah, you see that? No. I go back to R, just 1 second. Ah, yeah, you have to change the matrix, sorry. I couldn't understand why I was not getting the same eigenvector. I have to change the matrix. The matrix is, I didn't change it. So basically here, I think it was, yeah, 2.5. 2.5 here. Yeah, perfect. They are not the same value, but they are very close. Because you may remember that in R we got as maximum eigenvalue, we got 4.01. Here we still are at 4.04. The reason is that when I copied the eigenvector, I limited it to the 2 digits. In R they have much more, so this is why there is an approximation. So basically you can try to adjust the matrix in order to get close to 4, but still this situation is quite fine. There is 4.09 here, so the approximation is, but by changing the digits you should get to the same value that you get now. So basically, you know, I think we still work a bit in order to improve the situation, but you know, it's already quite consistent. And so these are the resulting weights. So basically we are giving 0.49, half of the weight to the economical benefit, and then we give 0.15 to the ecosystem. You may remember that we decided the ecosystem is more important than the landscape, and in fact you see that the landscape gets 0.27. And then we decided that the tourism was more important than both ecosystem and landscape, and this is reflected by the weight, which is 0.29. So, this is the situation. And of course, if the matrix increases in size, then it becomes more complicated. And now we are still not getting to a decision. We just decided the criteria and the weight to assign to the criteria. We decided the criteria and the weight to assign to the criteria. And now, of course, we should evaluate the alternatives for the design. The alternatives could be, for instance, 3 possible values of the design flow, and then for each one of these values of the design flow, we should give a number for each of the indicators. So we could say that the design flow equal to 10 gives an economical benefit equal to 100. A design flow equal to 20 gives an economical benefit of 150, for instance. So we should be able to assign to each alternative a value of the indicator. And then we can combine through the weight the values of the indicators. But this is the subject of my next lecture. In my next lecture, I will explain to you how we can combine the values that we assign to the indicators for each alternative design. Okay, that would be it for today, and but we still have 10 minutes if you want for questions, discussion. 10 minutes or even more, I mean. But at least 10 minutes, at least, if we don't decide that we don't have any question or discussion.
Next lesson we have to take the PC or?
No, on Monday not. But on my plan is on Monday I'm teaching for 3 hours the theory, and then we should get to the end of we should close the theoretical part of the subject. And then on Thursday again PC, and then we close. This is my plan. Maybe on Thursday, you know, maybe that I take 1 hour of teaching and 2 hours of PC. Do you have any question on today's? Anyway, let me say that it's important that you gain some skills in programming. This is extremely important, you know, and I'm not saying this don't be discouraged, it's easy to get that. But it's really important that you take the opportunity to write codes and to learn something, because of course when you do your profession, when you will be working, it's important to be able to use commercial software, but it's also much important that if needed you can write codes. And I can tell you, because you know sometimes the commercial software cannot solve all the problems, and therefore it's useful to be able to play with MATLAB and R, and this is extremely important for you, for your CV. I mean, it's, and any time that you dedicate to learning some software like CAD, like Excel, Word, or learning to use a different operating system like Linux, it's always time that is well spent. So I strongly encourage you. And because you know, once that you have the tools, then you can select the best one. If you just know Windows, you are just binded to Windows, and you can't change. Questions? No? No question?
But I have a question.
Yeah.
But for recognize see the first eigenvalues
Yeah.
on the R. It must be equal to the dimension of the matrix.
Yes, it should be.
Sure.
It should be, yes. If it is consistent. If it is largely inconsistent, then you could get a value that is much different from the dimension of the matrix. I'm sorry, I never had the opportunity and the necessity now to compute eigenvalues and eigenvectors, so I can't really play well with these routines. And I just went by intuition, so I looked at it, and my feeling is that by taking the module you get the 4 eigenvectors and you get the highest one. But I'm not really expert on that because it's, as I said, it's quite unusual for us to be forced to compute eigenvalues and eigenvectors of matrices, in my, let's say in hydrology at least. I think that in structural engineering probably they are more used to that.
And for the choosing of the column is always intuition.
Yeah, it's. I took the reasonable one basically, and the real one, because the other are complex. But you basically one should get, because the eigenvalue and eigenvectors, they are all real. So the reason why R gives it in the complex form is probably related to the fact that when you do some computation with complex numbers, and if it's related to the fact that probably R is capable of computing eigenvalue and eigenvectors for complex matrices. This is my feeling.